All right, hello and welcome to a walkthrough of the Exam 1 practice key. So the practice for Exam 1, and this is the answer key that I'll just kind of walk you through. We have our equations of kinematics that got kind of jumbled together here on the data sheet, but V equals V naught plus AT, X equals 1/2 V naught plus V times T, X displacement equals V naught T plus 1/2 AT squared, and then V squared equals V naught squared plus 2AX, and that's relevant for both the X and Y axis, and we'll handle them separately for two-dimensional kinematics. We have the acceleration due to gravity, negative 9.8 meters per second squared. I give you information about basic trig functions. Do remember that A squared plus B squared equals C squared. I don't seem to give that explicitly here. We have friction to deal with. We have a maximum static frictional force as well as kinetic friction. And then just the normal stuff that we would have to remember about forces. The normal force on a typical day, if you're just standing there on the floor, is going to be equal and opposite to your weight. But if you were standing on an elevator, then it would be mg plus ma. And then there's all sorts of other ways that the normal force can be convoluted, including when we have an object on an inclined inclined plane, the normal force is going to be mg cosine theta, and then that force component of the weight that accelerates an object down the incline is going to be mg sine theta, and that motion may be opposed by friction. This is all information that I will give you on the equation sheet. So now, as we tackle the exam itself, we have a three-toed sloth that is moving, that is the slowest moving land mammal, and we want to consider the sloth's speed relative to the giant tortoise's speed, and how far how much further the tortoise would have traveled relative to the sloth after 120 seconds. So we take our knowns and unknowns. I know initial velocity, which is actually also final velocity for both of these creatures, and I have time. So I only know two. Well, wait, there's another one. There's also acceleration. Acceleration is 0. We're talking about average speed, so for the duration of this 120 seconds, we're going to assume that these creatures are traveling at this constant fixed speed. So the equation that we use is actually x equals v naught t plus 1/2 at squared, but the 1/2 at squared disappears when the acceleration is 0. So this is an equation that we knew before class started. Distance equals velocity times time. So the distance that the sloth travels is the velocity of the sloth times the time. And please, please, please don't grab this one, 1/2 v naught plus v, and pretend that one of them is 0, because nowhere does it say that one of the velocities is 0. It says that the velocity is 0.037 meters per second the entire time. So 0.037 meters per second times 120 seconds equals 4.44 meters for the sloth. And then we do the same thing with the tortoise's velocity, and we get 9.12 meters. And so how much further would the tortoise have gone relative to the sloth? 9.12 minus 4.44 gives us 4.68 meters for the distance for the sloth. For the tortoise, how much further for the tortoise? All right, a little bit of information, a little bit of practice on doing conversions. So 70 micrometers or micrometers, there's 1 million micrometers in a single meter. So we're able to do that conversion to meters pretty easily. We'll have micrometers in the denominator, meters in the numerator. We cancel out and we wind up with an answer in meters, and it's 7 times 10 to the negative 5th meters. If we want to then convert into kilometers, what we would do is start with the base unit, meters. I wouldn't go back to micrometers. Start with the base unit in meters, and then 1 kilometer has 1,000 meters. Meters cancel, and I do 7 times 10 to the negative 5th divided by 1,000 gives me 7 times 10 to the negative 8th kilometers. Number 3, you walk from your home to the library, then to the park. What is the distance traveled and what is the displacement? So there's a difference, remember, between distance and displacement. Displacement is your final position minus your initial position. So this person, you, I suppose it is, start at your house, travel 0.75 miles to get to the park, and then you keep going, and you're going to go to the library, so another 0.6 miles to the library, and then you check out a nice book and you walk back to the park another 0.6 miles and hang out and read your book, right? So that's 1.95 miles that you've traveled in distance. However, your displacement is just your final position minus your initial position. Your final position is here at the park, 0.75 miles away from position 0, which was your house. So it's basically a numerical question that is getting at a conceptual point. All right, so if we were to walk back and forth in lab in front of the motion sensor and get a position versus time graph that looked something like this, we could figure out our velocity for each of those segments. The velocity for segment A is going to be the final position, that's position 1 meter, minus the initial position, that's 3 meters. 1 minus 3 is negative 2, divided by the 2 seconds it took to undergo that journey. So negative 2 divided by 2 equals negative 1 meter per second. For part B, segment B, we're going to travel final position, positive 3, initial position, positive 1. So 3 minus 1 is positive 2, divided by the 1 second is going to give us positive 2 meters per second for that segment. That's the velocity there. Same deal for segment C, 2 minus 3 is negative 1, divided by 2 gives us negative 1/2. So on this position versus time graph, if the slope is downward, then that's a negative velocity. If it's upward, it's a positive velocity. Okay, now we're into the world of a little bit of baby trigonometry. So we're traveling to the library. It's 50 meters down Birch Street and then 70 meters due north up 2nd Avenue. Give the magnitude and direction of the vector that describes your displacement. So a squared plus b squared equals c squared. We know a and b are 50 and 70 meters respectively. So 50 squared plus 70 squared is a big number. Take the square root of that number and I get 86 meters is the distance. It's the vector r here. And then for direction has an angle with compass reference points. And so I know the opposite value and the adjacent values are 70 meters and 50 meters respectively. So inverse tangent of 70 divided by 50 gives me 54.5 degrees. And what I would do is I would face west and then angle 54.5 degrees north in order to travel the 86 meters to get to the library. So I would describe this as 54.5 degrees north of west. Number 6. You're designing a new airport. One type of jet requires a speed of 30 meters per second to take off. The plane accelerates at 1.8 meters per second squared. What is the minimum runway length required for this plane to take off? And so I know the initial velocity for my jet is 0. I know the final velocity to take off is 30 meters per second. and I know that my acceleration is 1.8 meters per second squared. So I don't know the distance, neither do I know the time, but I don't care about the time, so I look at my 4 equations of kinematics, find the one that doesn't have time in it, and I get v squared equals v naught squared plus 2ax. What I want to solve for is x, so I do v squared minus v naught squared, and then I divide that by 2a. v squared minus v naught squared divided by 2a is final velocity 30 meters per second squared minus 0 meters per second squared, so I didn't bother writing in the 0, divided by 2 times 1.8. Notice I put a ton of parentheses here. You got to make sure that you multiply through the denominator before you divide here. And that gives me 250 meters. Run through these things on your calculator. I show you something here and the answer. Run through it with your calculator to make sure that you get the same answer that I do, because if you don't, then you did something wrong, and you might have done 30 squared divided by 2 equals something times 1.8, and you would get a different number, and that would be the wrong answer. All right, so we're celebrating a victory and throwing the glove straight up in the air with an initial speed of 6 meters per second. How long does it take for the glove to return to the pitcher, and how long does it take to reach its maximum height? Really, part B is easier to answer. Answer part B and then double it to get part A. So we know the initial velocity is positive 6. We know the final velocity, its maximum height, is 0. We know the whole time the glove is being accelerated back down toward the Earth with an acceleration of negative 9.8 meters per second squared. So V equals V naught plus AT. This T is the T that it takes to go up. So we solve that one for T, and we get the final velocity 0 minus positive 6 divided by negative 9.8 equals 0.61 seconds. It takes 0.61 seconds to reach its maximum height, and then it'll take another 0.61 seconds to come back down again. So the round trip takes 1.22 seconds. Hey, gulls are often observed dropping clams and other shellfish from a height to the rocks below to open those shells. If a seagull drops a shell from rest, so the seagull's just flying up there hovering 17 meters above the ground, how fast is the shell moving when it hits the rocks? All right, well, in that case, we're just interested in the y-axis. The initial y-axis velocity is 0. The y-axis displacement will be negative 17 meters. It will fall down, and then it will be accelerating downward at negative 9.8. That's an extraneous dot there, so ignore that one. That's not a decimal place. This one is. So the final y-axis velocity, v squared equals v naught squared plus 2gy, is going to be the square root of 2gy, which is negative 18.3 meters per second. Remember, when I take the square root of a number, the answer is positive or negative that number. Well, in this case, it's truly negative because it was moving downward. So that's my final y-axis velocity. I have to step in with a bit of logic and put that number in. The second part of the question was, if the gull was flying horizontally at 5 meters per second, that would be this vector, 5 meters per second in the positive x-axis, negative 18.3 in the negative y-axis, and I'm solving for the hypotenuse. A squared plus b squared equals c squared. I would get a velocity of 19 meters per second, and I could actually figure out the angle and stuff if I wanted to. In this case, it didn't ask that question. It just asked how fast is the shell moving when it hits the rocks. So I just solved for the velocity, and I gave the magnitude of the velocity. I could give the direction too if I was a better person. All right, this is a little more fun with vectors. This is vector addition, and what we're talking about is the relative velocity. So the velocity of the ground relative to you, and the rain relative to u. So what we do when we do this vector sum, if we want to figure out the velocity of the rain relative to u, we're going to add up the velocity of the rain relative to the ground and the ground relative to u. It's kind of a weird concept, but the rain is falling down on you. Okay, I get that part. So the rain relative to the ground, the rain relative to you are both the rain's coming down. But as you're moving forward, it looks to your eyeballs that the ground is moving backwards, right? You know, if you're moving forwards, if you're on a golf cart or a Segway or something, what you would feel like is, oh, hey, look out there, the ground's moving backwards relative to me. So it's kind of a egotistical way of viewing the world. But what we get is a vector of the ground relative to you, the rain relative to the ground, and then the vector sum, the rain is falling down on you at an angle like this. So for you to hold an umbrella and stay as dry as possible, you would angle the umbrella forward a little bit, maybe not this extreme. Hey, this is a shocking turn of events. This football question is on the exam, just like I told you it would be around 100 times. So here you are, you're at a football game. The ball is kicked, with an initial velocity of 25 meters per second at an angle of 40 degrees above the ground. What is the maximum height that the ball achieves? Well, I know any question that comes from this will involve doing the most important thing ever. If I plug that number 25 meters per second into any equation right now, I will get the wrong answer and I will make the person who grades the exam insane. So I'm not going to do that to that poor guy. So I'm going to get rid of that 25 right away. I'm going to say, hey, this ball has an initial x-axis velocity vector, 25 meters per second times cosine of 40 degrees, of 19.2 meters per second in the positive x-axis, and an initial y-axis velocity vector of 16.1 meters per second in the positive y-axis. So now I know this much. Now I can answer any other question. So what is the time it takes for the ball to reach its maximum height? Well, I know I can figure that out because I know the initial y-axis velocity is 16.1 meters per second. I know the acceleration due to gravity, and I know when the ball reaches its maximum height, it will have an instantaneous velocity of 0. Therefore, just like the pitcher throwing the glove up in the air, v equals v naught plus at. So t equals v minus v naught divided by g. So 0 minus 16.1 meters per second divided by negative 9.8 gives me 1.64 seconds. It will take this glove 1.64 seconds to reach its maximum height. This isn't the most efficient way to solve for the maximum height, but for some reason I decided to do it this way. Now I can plug that into y equals v naught t plus 1/2 gt squared, and I would get a maximum height of 13.2 meters per second. You could also solve this v squared equals v naught squared plus 2ax and solve for x. You would get the same answer. But now that I know the time, how far away does the ball land in the x-axis? Well, I know if it took 1.64 seconds to get up to its maximum height, it'll take another 1.64 seconds to come back down. So 3.28 seconds total time in the air. I know that my x-axis velocity is 19.2 meters per second the whole time. So 19.2 meters per second times 3.28 seconds gives me 62.9 meters for my x-axis range. Hey, what if I played football on Mars and the acceleration due to gravity on Mars is 3.77 meters per second squared? Well, what is the maximum height? I can do the same process that I just did and figure out that the maximum height would be 34.3 meters. Hey, I got abducted by aliens and now I'm on some strange planet and I want to decide what the acceleration due to gravity is. So I drop my car keys from a height of 1.3 meters and measure the time that it takes to hit the ground as 0.5 seconds. What is the acceleration due to gravity on this strange planet? And so I'll say I know my distance is negative 1.3 meters, I know the time is 0.5 seconds, and I know my initial velocity was 0 meters per second. So I'm going to solve this for g. Say my initial velocity was 0, so that thing disappears. Y equals 1/2 gt squared. That means that g equals 2 times y divided by t squared. 2 times negative 1.3 meters divided by 0.5 seconds squared gives me negative 10.4 meters per second squared. I actually have another mistake there. And that would mean that within a margin of error, I'm probably still here on Earth. Maybe that was just a bad dream. Hey, this is a question that I have frequently put on exams because I can ask different things about it. But here's the basic version. I have F1 and F2, and what is the normal force? So the normal force is the force pushing up from the floor. So on a day when there was no force 1 or force 2, if I just had a 5 kilogram box sitting on the floor, I would say the normal force is 5 kilograms times 9.8 meters per second squared. And I would have a value for the normal force, equal and opposite to the weight. But it's larger than that now, because not only is the normal force equal and opposite to the weight, it's also equal and opposite to the weight plus the y-axis component of force 1. So force 1 is 75 newtons. The y-axis component is going to be sine of 65 degrees. So I get a normal force of 75 newtons times sine of 65 degrees plus the actual weight of the box, 5 kilograms times 9.8 meters per second squared, and I get 117 newtons. Now there's other questions I could ask. I could give you frictional coefficients and ask you if it's moving to the left or the right or what's its acceleration, all sorts of things we could do. But this is the start of a larger question. All right, we have the fan cart in lab, and the fan is providing a constant 5 newtons of pushing force. What is the acceleration of a 500-gram cart? Well, newtons are kilograms times meters per second squared. So in order to deal with 5 newtons, I have to convert my mass into kilograms. So force equals ma, force is 5 newtons, mass is not 500 grams, but 0.5 kilograms. That's 500 times, there's going to be 1,000 grams in 1 kilogram, so I get 0.5. And then I say acceleration equals force divided by mass, and I get an acceleration of 10 meters per second squared. If I take that same situation and I add another 500 grams of mass to the cart, then what would its velocity be by the end of a 2-meter long track starting from rest at position 0? And so the acceleration this time is going to be 5 newtons divided by 1,000 grams, or 1 kilogram, so 5 meters per second squared. I cut my acceleration in half, and now I know my initial velocity is 0, I have my acceleration, I have a distance, so v squared equals v naught squared plus 2ax, v equals the square root of 2ax, and I get 4.47 meters per second. shouldn't say squared. I was not very good when I was making up this answer key. But we're almost at the end. Takes a force of 10 newtons to start a 2 kilogram textbook sliding across the table. Only takes 6 newtons to keep it sliding at constant velocity. What are the coefficients of static and kinetic friction? So that's just definitions. Fs max equals coefficient of static friction times the normal force. The normal force is mg, so coefficient of friction is Fs max divided by mg. I get 0.510, and then kinetic friction, I got 0.306. Number 18, if I were to ask you questions about Newton's laws conceptually, I would want something that isn't just equations. I would want to have some description that goes beyond F equals ma for Newton's second law. So you can have the equation, but also have words that describe it. That tends to stay in motion. All right. Number 19 is our first and only inclined plane question on this particular practice exam. No guarantees that there won't be more questions in more detail on the real exam. But if a 60 kilogram person slides down an incline at an angle of 35 degrees below the horizontal, what are the magnitudes of the normal force and the accelerating force? So just like we discussed earlier, normal force on an inclined plane equals mg cosine theta. So mg cosine of 35 degrees, 482 newtons of normal force, and then the accelerating force, 60 times 9.8 times sine of 35 degrees, 337 newtons of our accelerating force. And then I could ask questions. If I gave you coefficients of friction, I could ask you what their acceleration is going down that inclined plane. So 50 kilogram sled slides along a horizontal surface that has a coefficient of kinetic friction of 0.25. If its velocity at point A is 10 meters per second and its velocity at point B is 4, what is the frictional force acting on the sled? There's a lot of superfluous information there. You shouldn't be plugging in the numbers 10 and 4 anywhere. All I'm asking is the frictional force. This could be part A of a larger, more complex question later on. But for right now, frictional force, if the 50 kilogram sled is on a horizontal surface, then we would draw a free body diagram. We'd have weight going down, normal force going up. The normal force is equal and opposite to the weight. So 50 kilograms times 9.8 meters per second squared. And then kinetic friction is going to be, because it said it's sliding, so it's not static friction, 0.25 times the normal force, 122.5 newtons. This is not at all the full extent of questions that could be on the exam, but this is a sampling of questions and the way that I might ask them. So look at quizzes, look at homework, and look at the practice exam, and you should be in good shape for the exam.